Hey everybody, wanted to introduce you to our next unit that we're going to be covering. I happen to be at a golf match today out in Queen Creek, Arizona with my golf team. And with that being said, wasn't going to be able to talk to you all today, so wanted to introduce our next topic. And Mr. Reinhardt will let you know where to put this in your comp book. We're going to be doing one definition today, and then we're going to jump right into delta math to show you how to apply that definition. All right, so the definition that we're going to put in our book, and right now we just have to write down the first word of it, is called functions. All right, now I'm going to tell you right away this definition, if I just give you the definition, it's going to be a little bit messy. So let me explain it to you first. I have my wallet over here, and let's say that I had a dollar bill in here, so I've got a dollar bill. And let's say I were to go to the soda machine outside. How many sodas would I get for this dollar? Well, I'd get one soda for it because that's how much the soda machine costs. Every time I put a dollar bill in, I'd get one soda. I could get a different kind of soda, but I get one soda for my dollar bill. I couldn't get two sodas for it. I couldn't, put it in and get a half a soda. I get one soda for this dollar. That's what a function is. It's a machine, essentially a machine where we put something in and we get something out. And we know what we're going to get out each time based on what we put in. I put a dollar in, I get one soda. All right? I'm not going to get two sodas, and we're not going to assume the machine is broke or anything like that. A function, all it is, it's a machine. Think of it as a machine. I put something in, I get something out. So if we were to put that like into more official words, and this is the definition, again, it's going to be a little bit messy, but if we keep in mind kind of this idea of a machine, it should be okay. So here's what a function is. It's a relationship between an input and that input is always going to be called our x value, and an output and that output's always going to be what's called our y value. I'll explain that more in a minute. Where each input has exactly one output. So in my example of the soda machine, my input would be my dollar bill. My output would be the soda I get. I put a dollar bill in, get a soda out. And I'm going to have exactly one output. I'm only going to get one soda for that dollar. I'm not going to get 5 sodas or 10 sodas or half a soda. I only get one soda for it. So if you need to stop the video for a moment to get that definition, go ahead and do so. But I'm going to go ahead and move on. But again, you can stop the video if you need. And we're going to look at some delta math. All right, so let me erase this stuff. The first delta math problem I go over, we're going to kind of do it the long way. And you're going to do it the long way as well, because we need to know how to do that. But then I'll show you a trick. All right, so what we have here, delta math, it says, which set of ordered pairs represents a function? Well, first we have to know what an ordered pair is. 6 and 8, that's an ordered pair. It's two numbers, they go together. -4, -2, -7, 4, -7, 8, those are all ordered pairs. And you can see I've got 4 choices here. So what we're going to be doing in this problem is we're going to be selecting one of these choices for which one of these ordered pairs represents a function. Which one of these ordered pairs represents a function? Right? So that means that 3 of them are going to be the wrong answer. 1 of them is going to be the correct answer. Okay? Now, let's go ahead and take a look for how we're going to do this. First, what we're going to do over on this side here, I just want you to put the, and you can do this in your notebook, but over here I'm going to put map diagram. I'm going to put X, Y. I'm going to make a big old bubble on it. Make a big old bubble on my Y as well. Okay. And what we have to know about these numbers over here, the first number is always X. Second number is always Y. Okay. So imagine this, like this XY, imagine that we have a machine. I put 6 into the machine, so I put $6 into the machine, I get 8 out of it. On this one, somehow I put -$4 into the machine, and I get 2 out. On this one here, again, -7, get 4 out. This one here, -7, and I get 8 out. Okay. So what we're going to do on this first thing called the map diagram is we're going to go ahead and put our X values in order from smallest to biggest. So I've got an X value of 6, -4, -7, -7. Well, the smallest X value is -7. And I'm only going to write it down once. Even though it's listed twice, only write it down once. We only need to write it once. Next one is -4. And the next one is 6. Same thing with my Y values. Take a look at the Ys. I've got 8, 2, 4, and 8. 8, 2, 4, and 8. What's the smallest Y value? It was 2. Next smallest Y value was 4. And the next smallest was 8. And I only write it down once. And now I connect some lines here. So the -7, what does that go with? Well, it goes with 4. And it goes with 8. -4 goes with 2. And 6 goes with 8. Last thing I'm going to do right here is I'm going to draw a big kind of cross like that. We're going to go ahead and graph this. Okay? And I'm going to show you, we're going to find our answer in 3 different ways right now. And I'll show you a trick in a moment for how to do this in a shorter way, but right now we got to kind of get the bigger picture. So we're going to graph these. So we got 4 different points here. We're going to graph these points. This line that goes left to right is my X line. This line that goes up and down is my Y line. Everything on this side of the X is a negative number. Or, I'm sorry, this side of the Y is a negative number. Everything on this side of the Y is positive. Everything above the X line is positive. Everything below this X line is negative. So let's always start with 6. Let's start with our first number here, 6, 8. So I go 6 on the X line, 1, 2, 3, 4, 5, 6. And then up 8 on the Y, 1, 2, 3, 4, 5, 6, 7, 8. So here is that first point, 6, 8. Next one, -4, 2. -1, 2, 3, 4, up 2. Next one, -7, 4. 1, 2, 3, 4, 5, 6, 7, up 4. Up 1, 2, 3, 4, right here. -7, 4. And then I've got -1, 2, 3, 4, 5, 6, 7, up 8. 1, 2, 3, 4, 5, 6, 7, 8, right there. So now I've got my ordered pairs, I've got my map diagram, and I got this chart right here. Now I'm going to tell you right now that this one is not a function. This one is not a function. How do I know that? I'm going to know that in 3 different ways. Okay? I'm going to show you each of those 3 ways. First, on this right here, imagine again, we had a soda machine. I know I can't put -$7 into a soda machine, but let's say I could. Well, it should only give me 1 output, right? I put something in, and it should only give me 1 output. But here I've got 2 outputs. -7 results in an 8, and -7 results in a 4. If I put something into a machine, I should only get 1 output. So we know that's not going to be a function just because of that right there. Here's another way that you can tell. It's called the vertical line test. When I graph something, if I can draw a vertical line, an up and down line, through 2 of the points, it is not a function. So I can draw a vertical line right through two of those points, not a function. And here's a third way that you can tell. -7 repeats. If I've got a number on the x value that repeats, it is not a function. So those are three ways to tell right there. So we know this one is not correct. Let's take a look at this second one. And let's first start off by seeing if there's any numbers that repeat. So I've got any x values that repeat. xy, 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 xy. Are there any x values that repeat? 0, 3, 0, 6. Well, right away I see the zeros repeat. So I know this is not going to be the correct answer, but just so we can do it, because I want you to get this practice as well, let's go ahead and do the map diagram and let's graph it. All right, so let's go ahead and do the map diagram first. What's my smallest x value? We've got 0, 3, 0, 3, 0, 6. So 0 is my smallest. The next smallest is 3. The next smallest is 6. What about my y values? I've got 9, 5, -4, and 2. So my smallest y is -4. My next smallest y is 2. My next smallest y is 5 and 9. So 0 goes with 9. 3 goes with 5. 0, I'm looking over there, 0 goes with -4. And 6 goes with 2. Well, what do I notice right away? 0, all right, has two outputs. I cannot have an input that has two outputs. It is not a function. So I know that's not going to be correct. Let's go ahead and graph it on here anyway. So I've got 0, 9. So 0 is right in the middle, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. What else do I have? 3, 5. 1, 2, 3, up 5. 1, 2, 3, 4, 5. Then I've got 0, -4, 0, 1, 2, 3, 4. And finally, I've got 6, 2. 1, 2, 3, 4, 5, 6, up 2. All right. So this would not pass the vertical line test because I've got a dot right here at 0, 9. Another one right there at 0, -4. Those two, if I do a vertical line test, not a function. All right, so I know this is not going to be the correct answer. Let's take a look at this one here. So let's first take a look to see if any of our x's repeat. 6, -7, -4, -9. This one's looking like it could be a potential here. None of those x values repeat. Let's go ahead and do it over here though. So xy. So what's my smallest x value? -9. See that right there? -7, -4, and 6. Then what are my smallest y values? I've got 0, 2, -8, and 2. -8 is the smallest. 0 is the next. And 2 is the next. And again, I'm only going to write down the 2 once because I only need to write it down once. I don't care how many times it appears. Now let's go ahead and map this out. So 6 goes with 0. -7 goes with 2. -4 goes with -8. And -9 goes with 2. Now, one of the things we want to notice, the 2 has 2 lines going to it. That's okay. That can still be a function. You can have as many arrows as you want going to a number multiple times on this y grid, on this y bubble. It just can only be from one x value. You can only have one line coming from each x value. You can have multiple lines going to the same y value, like we have here. -9 goes with 2, -7 goes with 2. But look at, only one line comes from -9, only one line comes from -7. So far, this looks good right here. Let's just go ahead and graph it and just double check everything. Make this nicer again. Sorry, I know that line's a little bit skewed, but that's okay. So 6, 0. 1, 2, 3, 4, 5, 6, 0. Negative 7, 2. Negative 1, 2, 3, 4, 5, 6, 7, up 2. 1, 2. Negative 7, 2. Negative 4, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, and then down to 8. Negative 4, negative 8. And then finally, negative 9, negative 2. Or negative 9, positive 2. Negative 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 7, 8, 9. We'll kind of do it right there. And up 2. So that's negative 9, 2. This passes the vertical line test. I could draw a vertical line over each of these. Right here. Right here. I could draw a vertical line over this guy and over this guy. They don't intersect with another dot. So this one looks good. So map diagram's good. Our chart is good. And then check this out. I don't have an x value that repeats. Nothing repeats. No x values repeat. So that's going to be our answer right there. And I'm not going to do this final one, but how would we check it really quick? Do any x values repeat over here? So I've got xy, 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 xy. So I've got negative 5, 0, negative 5, boom. I already found 2 that repeated, won't be a function. So if I go ahead and submit that answer, and it tells me I'm right, and that's good. Now, these are going to be the types of problems you're going to be doing. And sometimes you're going to see them like this, where they say, if we just read this down here, it says, which set of ordered pairs does not represent a function? All right, so then we're going to be trying to find the one that is not a function. And then other times you're going to have ones that say which one is a function. All right, so as long as you remember that it is only a function, if each x value only has one line coming from it. X values cannot repeat. If the x value does not repeat, it's a function. If it passes the vertical line test, it's a function. All right? So that's going to be your homework. Mr. Reinhardt will let you know which problems to complete. Good luck and have fun.